Thank you and welcome everyone. So this is just the start, and as a part of Neural Nexus 23, we are going to organize a lot more events and challenges and talks, and hopefully you guys will be part of that, and we're stoked about that. So today's topic is Introduction to Machine Learning and its applications, obviously as the slide says. So I want to preface this by saying that this is not going to be an exhaustive workshop. We are not going to teach you everything, but hopefully we'll give you enough words to Google about, and hopefully you will Google what you can know from the words that you search in Google, from the words you get here, and this will give you a sense of direction for whatever you are interested in ML. So let's get started. Just the previous slide. Just back this. Yeah. So let's get started. So we have been building technology for ages to reduce our work. Like for example, in the Industrial Revolution, we discovered something called as the steam engine to reduce our work. And today that we are going to do the same thing for reducing our mental work through the AI revolution. Akin to how we simulated mechanical muscles from the steam engine, we are today trying to revolutionize by simulating the human brain. So how do we do that? How do we make something that recognizes the difference between English or a Hindi song, or recognizes the difference between, let's say, a cat and a dog? How do you make something creative? How do you create creative content from a machine without a human involved? These are just some of the problems we try to solve using ML. The problem of simulating some of our basic senses and skills. But let's slow down and move on to the basics. So what is machine learning, and more importantly, what is artificial intelligence? Next slide. Yeah. So at the core of artificial intelligence, it is a branch of computer science that replicates human intelligence in machines. Anything that makes some sort of intelligent decision. For example, a program that tells you if something is if a number is odd or even that can be considered as artificial intelligence. However, AI is constantly evolving, and what was considered as AI in past may now just be looked at as a computer function. For example, a calculator may have been considered an artificial intelligence of some sort in the past, but now it is just considered to be a simple functionality. So let's move on and let's learn what's machine learning, which is the main hotspot for development in AI today. Artificial intelligence is when computers can do something that usually needs human intelligence. For example, like playing a game, recognizing faces, or answering questions. Machine learning is a type of artificial intelligence that helps the computer to learn from data without explicitly being programmed to do so. For example, you can recognize spam emails by analyzing the examples of what can be considered as spam or what is considered as not spam. And now one level deep is deep learning. Deep learning is a specific type of machine learning that uses an algorithm called neural networks. These networks are modeled after the human brain and can learn. Yeah. These. Okay. These are modeled after the human brain. They have something called the neuron. They have multiple levels of neurons which can be used to train it on different breeds of dogs, for example, by analyzing thousands of images. And then this AI can tell the difference between various types of dogs just based on the picture. So, in a nutshell, AI is an umbrella term for making machines intelligent. ML is a technique that enables machines to learn from data, and deep learning is a special kind of machine learning that uses artificial neural networks. So I'll now hand off over to Madhusudan.
Oh yeah, so now by now you must have got an idea what ML is. So let's see how ML actually works. Any ML just works on algorithm. So as the slide says, an algorithm instructs a computer to complete a task And in machine learning, it predicts output values within an acceptable range by analyzing input data. As you can see on the slide, there are various machine learning algorithms like linear regression, logistic regression, LSTMs, and so on. As these algorithms receive new data, they learn to optimize their processes, meaning they can improve performance and become more intelligent. Yeah. So let's see and let's look at this with an example. As said by Tom Mitchell, a computer professor, a computer program is said to learn from experience E with respect to task T and some performance measure P if its performance on T as measured by P improves with experience E. Let's understand this diagram with an example. Let's say we want to build an model which detects whether an email is spam or not. Before looking in it, a quick question. Can someone tell what kind of problem it is considered in ML? Spam detection model. Yeah, it's a classification model. So, to start with the model, first we need data. You would start by collecting a large dataset of labeled emails, whether each email is classified either spam or not spam. This is the experience E. The data is the experience of the model. And then, now it's time to select an appropriate algorithm to train the model. The algorithm will learn to map the input features of the email to the binary output. Binary output says either a spam or a not spam by iteratively adjusting a set of weights, which we'll be seeing further. Once the model is trained, you can use it to make on new predictions, and this is the task. Our task is to make the predictions whether is the email is a spam or not spam. So that's the task, and the experience will be the data, and the accuracy that will, as this is classification model, we will be measuring the performance model on a metric called accuracy, and this accuracy is the prediction, the performance of the model P. Yeah, so now Ashutosh will continue.
In machine learning, there are three major ways with how we deal with making the machines learn from data. So the first kind of machine learning is supervised learning. So supervised learning is something when you already know the correct answers. For example, if a teacher gives you an assignment and tells you the correct answers, then you can learn from that. For example, you might have gotten question banks for your exams in your school curriculum. So this is kind of similar. You see the correct answers and then you learn to answer similar questions in the future. So you already have a data set and you have the answers. But the next kind, unsupervised learning, is not like that. You do not have the answers already, but you hope to find some sort of insight along the way from the data's distribution. Unsupervised learning is like when you're playing with toys and you start to group them based on how they look or how they function, and this is useful. And the most common type of unsupervised learning are clustering algorithms, which you'll be learning hopefully soon. And the last type of machine learning is reinforcement learning, which is as it sounds, based on reinforcement. So if you have a constrained environment where you have a fixed set of actions, like there's only three things you can do. You can jump, crouch, or just dodge. So there are three things you can do, and on basis of some sort of reinforcement. So if you do something correctly, then you get positive reinforcement, and if you do it wrong, you're getting some negative reinforcement. And hopefully from the method of trial and error, you learn to perform in that environment. So reinforcement learning is like when you're playing a game with your friends. You get points for doing something good or lose points for doing something bad. You learn to make good choices based on the points you get, and you try to get as many points as possible. And moving on, I would like to just categorize the domains in machine learning on some broad basis. So remember how I asked you, how do you recognize the difference between English or the Hindi language? How do you recognize the difference between a cat or a dog, or generate creative content? So based on the major senses that we try to simulate, for example, you can simulate the functions that eyes do. They take in visual media and convert it into some sort of inference in our brains. So that kind of data is dealt with in computer vision. computer vision deals with the evaluation of visual media. As you can see, we have a person dancing, and the computer is able to tell the pose. Computer is able to infer the pose from the image. So that is useful because you can then use this as some sort of pipeline to, for example, analyze sign languages. Sign languages can be analyzed by softwares and hopefully make the life of deaf and mute people easier. The other example you can see, as you can see, is an image of a very angry person, and the image is able to recognize that there is, and the software is able to recognize that there is a human face in that image, and it is able to tell that the person is angry. So there are kind of two things that are happening here. The first thing is an object detection. It is able to detect the human face, and the second thing that is happening here is the classification. What kind of emotion does the person currently have? So it might be happy, angry, or sad, and as you can see, the model is able to tell that this is angry. So that's a classification model. Moving on, how do you create visual media? For example, there's an artist and you want to draw images, but you're not a very good artist, but you need those images. So how do you do that with artificial intelligence? So for creating visual media, there are two major ways. First is GANs, generative adversarial networks, and the second is stable diffusion. We are going to explain that on a deeper level soon, but let's move on to the next slide. Now, dealing with audio and text media is done by something known as natural language processing. This first image is a word cloud generated on the word NLP. It has printed the words used in more similar contexts with larger size. For example, you can see that language is printed larger than something like criteria, because language is more correlated to NLP in the training data set that was fed into this model than criteria, and that kind of makes sense too, and language is in the name of natural language processing. Now this second image is an interesting, the AIVA, Artificial Intelligence Virtual Artist, is related to generating music from artificial intelligence through natural language processing. This is done via something called as transformers, which you can look up, which are a recent innovation that have helped in models like ChatGPT and Google Bard. So let me play this music for you, and you can just see for yourself how good the artificial intelligence has really become. As you can see, that's pretty good actually, even better than some of the current artists, I might say. And you can see how good it has already become, and this will become a major outlet for creative media soon too. So that's natural language processing, and we can move on to the next. So as I have spoken earlier about reinforcement learning, it tells you how to, it tells a model how to behave in an environment where you have a fixed set of activities. For example, in chess, you have only a few set of legal moves that you can make. So we train a model to learn how to make the best possible moves based on the number of games it has played. And if it makes a blunder, then we are going to tell it, then we are going to give it negative reinforcement. Otherwise, we are going to give it positive reinforcement. So this is how machines learn from trial and error. This second image you see is a table tennis playing model that has learned after playing lots of games too. So in a computer simulation, and this has been helpful in creating, this will be helpful in creating more general purpose AI sooner or later. The last domain I want to talk about are data analytics and time series. Data analytics is more related to crunching numbers, particularly in financial sectors, where in conjunction with some financial reports like sales analysis or stock reports, you are able to give some financial insights that can be then used to give data-driven solutions to different forms of problems. And time series is a subcategory of ML, which allows a computer to predict the future on the basis of the past as input. For example, researchers use the historical progression of number of cases in COVID pandemic to predict the next big waves. So it's useful in predicting that, and it is also useful in predicting stocks and lots of other things. So let me ask you a question. Suppose you have an AI that is able to diagnose a patient based on their X-ray. So which domain does this problem fall under? Can anyone answer that? Any show of hands? The first option is time series. The second is NLP, computer vision. So let me give you a hint. The answer is based on what kind of input you are giving. You are passing an image, an X-ray. So what do you think this falls under? CV, right? So that's the right answer, computer vision. You are able to train the model on different kinds of for detecting different kind of diseases based on the images it has seen. This has been used in cancer research. It has been used in MRIs and a lot of medical applications. So let's move on, and I'll hand over to Madhusudan.
Yeah, so let us look at some more applications of AI. All of us use search engines like Google and Bing on almost a daily basis. These use the state of the data analytics. These engines often come along with speech assistants like Siri or Alexa. These are implemented using natural language processing so that they can understand us and talk back to us. Fraud detection is crucial for large storing entities like banks. Usually banks use a software called Forex to detect the fraudulent transactions. AI also automates high-level jobs we would rather not do. Let's be honest, none of us want to be a call center employee. This process is automated using chatbots akin to ChatGPT or Bard. Medical decisions that previously required the opinion of specialized professions like radiologists and oncologists can now be automated by a bot instead. The application is not just limited to what human brains can do. These algorithms can do what a lot we cannot do, and in a much better way also. For example, the stock market. Advanced models can do stock trading in what we call as high frequency trading. There's a lot of money to be made in this domain, and hence the hype. And another example is meteorology. Humans are historically not very good at predicting weather, but now with the help of AI in meteorological departments, we are able to improve our predictions. They can also generate music, as you just saw, and images. For example, this image on the left right corner was generated by AI when asked to generate an image of MRI of a human brain. Yeah, thank you. Now Shivankar will carry.
Okay, so let's move on with some real life applications of ML. So let me ask you a question first. Have you ever wondered to create a ghost? If I would have asked that, have you seen a ghost, so you would have said that, yeah, I have seen it. He is sitting besides me only. So he has an AI tool that is a ghost generator. So this person does not exist. So basically this person does not exist is a website created by Philip Wong, a 33-year-old software engineer. So it basically works on the algorithm known as generative adversarial network, which is popularly known as GAN, which was developed by NVIDIA. So this algorithm renders the hyper-realistic images of completely fake people. So once you visit the website, and then tell what features, what specifications, what ethnicity you want, it will generate a fake image it will generate a fake image, and you can now use it in your projects or something that you want. So let's first see the demo of this website. Yeah. So let's say gender to be male, age between 19 to 25 of our age, ethnicity white, and refresh the image. So it will generate a fake image a completely new image. So yeah, this is the generated image. We can again refresh it. It will generate a new image. So yeah, tell me about any specification, any ethnicity that you want. Okay, let's take female now. Age 12 to 18, Asian, and then refresh the image. So yeah, again, it generated the image that we want. Now let's see how this actually works, the backend work on which it is doing its work. So how does this works? How these fake images, the fake faces are generated? So you can see in this diagram, on the slide, it all starts with a noise, what we call as noise. So noise is basically abstract representation of some sort of a list. Okay. So in machine learning, in 9 out of 10 times, the data is first converted into random numbers, and these numbers is then fed to our model. Okay. So a noise would therefore be considered as a list of random numbers. So this list is input to our first neural networks, known as generator. So this noise is then basically a list of random numbers is then fed to our generator. So our generator is capable of converting a large amount of noise into larger and more accurate pictures, layer by layer. But remember one thing, it generates a fake image. So we fed the noise to our first neural network generator, it produces a fake image of it. Now this fake picture, the fake image, is now fed to our second neural network model, which is known as discriminator. So the work of discriminator is basically a network which has been trained with more and more real images. So the discriminator model, our second neural network model, is trained on original image data, whose work is to basically distinguish between fake and real images. Okay, so it tells us in which category the image belongs to, whether it's fake or whether it's real. So you can basically see generator as a criminal and the discriminator as a cop. So it's basically generating the fake image. The discriminator work is to catch it's fake or real. So the generator will try to fool the discriminator, and discriminator will try to catch the generator. So basically they are in a phase that they are fighting with each other. They are in the phase that they are like something playing against each other in some kind of a game. So on a broader view, our generator model produces a fake image, which is then passed to a discriminator. It will now tell us the image is fake or real. This data, basically it's fake or real, is again fed to generator as well as discriminator to optimize itself. So if image is more to the faker side, the loss is more. Our main work that the generator wants to do is to maximize the gain, to produce more realistic images. Okay. So this optimization, this loss is now fed to generator and discriminator to train itself, to improvise itself. So both generator and discriminator will improve the generator will improve to produce more realistic images. The discriminator will improve to tell us the image is fake or real more accurately. So this is how our GAN model is trained. So our generator will thus now be capable of generating a hyper realistic model, the hyper realistic images of completely fake people. So this is how this person does not exist works. It generates the image through GANs. Now let me ask you a question. Which face is real? So basically there are limitations of GANs too. So can you tell me which face is unreal here? Which face is real actually? The left one. Okay. So yeah, you are correct. The left one is real because you can see a green patch in the hairs of the lady which is present on the right side, like the left side of yours. So basically that green patch you can see. So the GANs are more accurate on working on faces. It creates the hyper-realistic, the actual real images of faces, but it has some limitations on minute accuracies, just as hairs. So again, let's move on to the Next, right? So yeah, you are correct. Again, tell me which is fake or which is real. Take a guess. This is real? That one. Okay. So yeah, you are correct. The right one is real image. So here you can see there are asymmetry between the ears of the man on the left. You can see the asymmetry between the ears. So this is how GAN somewhat like leaves some have a less accuracy on small detailing of a image or piece. But again, these are some examples in which we can identify the difference. But if you want to catch every GAN generator image to be fake or real, you have to be like have a great observatory skills. So the website known as which face is real is you can like play on it to identify your observatory skills again. So now let's move on with the our next ML model known as Dolly. The world creates world. So Dolly is basically a text to image generator made by OpenAI that would generate realistic images from a description of a scene or object. So let me ask you a question. Do you know why doll A is known as Dolly? Why this name is given? Any guesses? So let me tell you. So this name is basically a combination of Slevader Dolly and a robot Wally from Pixar. Okay, so this is combining this ML model, this ML application is combining art and digital animations to using artificial intelligence. So it what makes the name Dolly for it, made by OpenAI. So let's see some demonstration of Dolly now. Before that, we can like take a brief work. How does the Picasso of AI works? So basically, you fed a text input. This text input is now fed to a clip model. Clip model is basically contrastive language image pre-training. Its results is then fed to diffusion model and it produces the image for us. So before moving to the detailed working of how this Dolly works, let's take a demonstration first. Okay, so tell me of who is good at drawing or something, imagination. So tell me a prompt for this, like the scene or that you want to create. Anyone?
A brother helping his sister in study.
Okay. So it will take us some time to generate the image. And you can see the image. You can now maximize the image too. Okay. So yeah, it has generated the image that we want. Let's take another prompt. Anything?
6 people sitting on a horse in middle of Pacific Ocean.
Okay. It's not that accurate on this because it's a coherent text. So Dolly is not good at coherent text. 6 people.
Sitting on horse.
Okay. Let's see. It will generate a random image now. So it has created people on sitting on horse in the ocean. So yeah, it's good at that. So now now moving on to how the Picasso of AI works actually in the detail. Okay, so our first model that comes into play is clip model. contrasted language image pre-training model. So basically CRIP represents the idea that a language can be a vehicle to teach computers how different images relate to each other. So formally speaking, you can now, it prescribes a simple way to carry out these things. How two images relate to each other can be like told by CLIP. You can now imagine taking a picture of a street and telling a computer to describe what's there. So it will tell you how many cars and signs are there, but it won't give you the exact essence of what the scene is described overall. So here the insight that makes CLIP so powerful is the bright idea to train model which will not only identify in which category a particular image belongs to, but also give you the caption for it. So basically CLIP is doing a completely opposite work that we want Dolly to do. Dolly is generating image from text prompts, and the our CLIP model is doing the just opposite thing. It will give you a caption for an image from a list of random captions, a perfect caption for the image. Okay, so this allows us the model to use language more precisely to understand the difference between Rahul and say Rahul wearing a gold chain. So this is what CLIPs do for us. So in accomplishing this pre-training task described here, CLIP is able to create a space whose dimension represent both features of an image and the text or the language. So it basically creates some sort of dictionary for us, image to text dictionary. We have English to Hindi dictionary, right? That helps us to communicate translate between these two languages. So this is what the CLIP does for us. So CLIP basically acts as a dictionary sort of thing for the computer between image and text. Now with this also, even we now imagine a scenario, you know Marathi words, you are translating it into Punjabi se. But again, to be proficient, to be able to speak perfectly, you must need to know the pronunciation and grammar of Punjabi before speaking it. So this comes in picture, our next thing. So basically you can see here, it's generating the caption from random captions, CLIP model. These pictures defines that only. So for that, to giving the crux before speaking the language, our next model that comes into picture is diffusion model. So let's move on to diffusion model now. So to understand this in a simple way, imagine a Rubik's cube. You have a Rubik's cube, right? It's completely solved with each side having blocks of only single color. Now you randomly choose a side from it and twist it till you have completely scrabbled Rubik's cube. Okay. Now again go back to so first imagine that you have lost all the data, all the steps in which you scrabbled the cube. Okay. Now you have a randomly open playground to go back to the state, the completely solved state. You can do it with any way you want, right? So you are basically going from a state of less disorder to high disorder and again back to less disorder. In the way, this is crux of our diffusion model that we are using here. So in a similar way, our diffusion model take a image, randomly scrabbles its pixel until you have completely pure noise. You cannot identify this as image. And now we train our model to reduce this noise by changing the pixels step by step again and again to get the original image or something sort of related to that original image. So this gives us a model that can generate images from noise, and with these variations, by doing this pixel variations, you can even get a new image from it. But again, to infuse these creations with the semantic meaning of text that we got from Dolly, that we want to generate. So we condition this model through the results of our CLIP model. Okay, so we basically pass the results of our CLIP model into the diffusion model that calculates which pixels to change upon in each step in the generation process to get our image that we want. So this allows the model to change the information or get an image which has a semantic meaning of text that we want, as well as the image that we want to produce. So this is how Dolly works. So if you have any doubts, you can ask. Basically, Dolly works on two things: clip and diffusion model all together. So Dolly consists of two models running in it. Clip model, its results is then fed to diffusion model, which ultimately produces the actual image that we want. So with that, I would like to invite Atharvya.
Now that we have discussed how AI is used for image generation using DALL-E, let's move on to another application, ChatGPT, which uses AI to generate natural language responses. ChatGPT is an AI-powered language model that can generate human-like language and respond to questions and statements in a conversational manner. You might be familiar with chatbots. These have been around for several decades. But what makes ChatGPT an NLP revolution is its large scale and learning capacity. Before we move forward, can anyone tell me who developed ChatGPT? Yeah, that was pretty easy, I guess. Here's a simplified explanation of how it works. It is based on an algorithm called GPT 3.5, a type of neural network. You can think of neural network as having a working similar to that of our brains. Large text data, such as books, articles, websites, is fed to this algorithm. The algorithm then tries to identify patterns and correlate things. By the large scale of training data, I mean the text data equivalent to roughly 60,000 years of spoken conversation. This massive amount of data allows ChatGPT to generate highly context-specific and human-like responses to user queries and requests, making it a significant breakthrough in conversational AI. Now, how do we use this now trained model to predict our queries? It generates text by predicting the next word based on its input. For example, if you ask it what is a language model, it will use its trained knowledge to generate a response that makes sense based on the context of the conversation. Another thing that makes ChatGPT stand out is that it continuously learns and improves over time. As it interacts with users and receives feedback, it can update its knowledge and generate more accurate and relevant responses. This continuous learning or adapting to new data is a form of fine-tuning our model. Now, can you answer this question? The correct answer is unsupervised learning. This is because during training, ChatGPT learns the patterns and relations between words on its own and then builds a statistical model on the basis of the language it has been trained on. So the training part is included in unsupervised learning. And do attend our workshop in the evening to learn how to create your own ChatGPT.
Okay, now let's look at another large language model, one called Google Bard. It is developed by Google as an answer to ChatGPT. Google Bard AI chatbot is an AI model developed by Google, and it uses deep learning algorithms called large language models to offer answers to text prompts. It aims to change the way we search for information using search engines. It presents in-depth answers to open-ended questions, distilling complex information from multiple viewpoints into an easy-to-digest format. Unlike ChatGPT, you need to join a waitlist to use Bard, and only users in the US and UK can use it currently. Now, how does it compare to ChatGPT? Now, first we look at the algorithm it uses. It uses Lambda technology and Webb data to give up-to-date and reasonable responses from its vast database it has been trained on. Now, coding. ChatGPT is widely used for coding as it excels in writing complex code in multiple languages. In contrast, Google Bard cannot currently code. Now, speed. Google Bard is faster than ChatGPT because the underlying model has fewer parameters. Additionally, ChatGPT has a lot of users, which makes it slower than Bard. Creativity and language support. Users claim that Bard is less creative than ChatGPT, and it supports fewer languages than ChatGPT's new GPT-4 model, which supports over 26 languages. Now let us look at a major problem in such AI chatbots. A major problem in these chatbots is their tendency to confidently state incorrect information as facts. These systems frequently hallucinate, that is, they make up information because they are essentially just autocomplete systems. Rather than querying a database of proven facts to answer questions, they are trained on a huge corpora of text and analyze patterns to determine which word follows the next in any given sentence. In other words, they are probabilistic, not deterministic, a trait that has led to one prominent AI professor to label them as bullshit generators. Of course, the internet is full of false and misleading information, but this issue is compounded by the fact that Microsoft and Google want to use these tools as search engines. There, these answers would take on the authority of a would-be all-knowing machine. Here we can see an example of hallucination. Visible? So here we can see an example of hallucination in Bard, where when asked what are the next months of the year, with the first 2 months being January and February, it gives just random answers like January, April, etc. Here there is another example of hallucination in Bard, where when asked what are the new discoveries from the James Webb Space Telescope, I can tell my 9-year-old about. It claims that James Webb Space Telescope took the very first pictures of a planet outside our own solar system, whereas it was done actually by Chow et al. In 2004 with the VLT NACO using adaptive optics. Now I invite Mr. Safdar to talk about the next case study.
हेलो हेलो पीछे तक आवाज़ आ रही है ठीक है थोड़ा दूर पकड़ता हूँ Okay, so a lot has been said about how AI is used, about these big models, but one important thing to note is for the majority of people using these models, in fact for a lot of people who even worked on these models, it is very hard for them to understand कि model के अंदर क्या हो रहा है. They are essentially black boxes. तुम उन्हें data देते हो. Is everyone comfortable with Hindi? ठीक है. So तुम उन्हें data देते हो, वो data को कुछ तो process करते हैं, data से कुछ तो सीखते हैं, and they spit out an output. This is particularly highlighted in the examples that we showed of is this face real, and the face generators essentially. So if you look carefully, like they mentioned during the workshop previously, there are certain inaccuracies here and there. ईयर थोड़ा ऊपर होगा या बाल कहीं से थोड़े गायब होंगे या if you see कभी कभी कपड़े थोड़े अजीब लगेंगे. There are many other faults you will come across if you use them in the future. That is because these models essentially take the image as a whole, train on it, and they essentially learn about the face as a whole. There are two eyes, there is one nose has two nostrils, one mouth, 2 ears. They don't necessarily understand कि नहीं आँख यहीं पे होनी चाहिए, नाक यहीं पे होनी चाहिए, perfectly symmetrical होनी चाहिए, कान ऐसे ही होने चाहिए, ear के अंदर की features ऐसे होने चाहिए. That is one of the major drawbacks that a lot of scientists are working on. Does anyone here know how capture works? Where do those images come from? What happens to them? Like why it is used as a human identifier? Anyone? Hint कुछ भी random चलेगा नहीं ठीक है. So what essentially happens is those are images which existing algorithms weren't able to classify properly. So they essentially throw it on websites, and what we as users do is label those images, which makes the job of any company very easy because today's world is data driven mostly. If you have the right sort of data, you can pretty much train any kind of model. So the fact कि वो हमें image देते रहते हैं, हम उन्हें label करते रहते हैं, just improves their own data set. सोशल मीडिया में हम इंस्टाग्राम पे या कहीं भी जब खुद का फोटो डालते हैं तो वी लेबल इट कि हाँ दिस, हम उन्हें टैग करते हैं. हम लेबल करते हैं हाँ ये फोटो सफदर का है, ये फोटो आशुतोष का है. So again, this feeds the data set that these companies have, and this essentially is a data set which face recognition softwares can be used on. So every time you tag someone in a photo on Instagram, you're essentially making it easier for them to build up surveillance state. So coming to this particular case study, bakery scan. This particular story is particularly close to me because this is what inspired me to take up MLAI, venture into this field. A little backstory before I venture into this particular model. Have you seen the images about the hundreds of different flavors of Kit Kat that are available only in Japan? Or kahin pe bhi nahi. They'll have banana, pineapple, sushi, whatever. And these flavors are available specifically in Japan, nowhere else in the world. देखा है? Aware, like new information नहीं है? हाँ ठीक. So that's because people in Japan value variety over anything else. A market research study that was conducted by the company who actually wanted the software built said that if a bakery had 100 different varieties of pastries, they will sell twice as much compared to if the bakery had only 30 varieties of the pastry, of different pastries. Now, the same company conducted another market research study which said that if a pastry good is presented to the user completely unpackaged, which essentially gives a perception of the good being freshly baked, it will sell 3 times as more. Now, when you combine both of these factors, if a company wants to maximize their sales, they will have to provide hundreds of different varieties which are unpacked. So there is no way to properly label them. You can't just put a barcode on it. So the problem arises that the problem which arose in this particular case was that the bakery would have to train humans to identify these goods. And I mean, let's face it, hundreds of different varieties. तुम सीखने जाओगे, बहुत सारे दिक्कतें आएगी. You'll have to like look at it for two minutes to make sure हाँ ये सही है ना, कहीं cheap वाला item तो नहीं दे रहा हो, stuff like that. तो essentially training time बहुत ज़्यादा था. So to combat that, the bakery approached a company called Brain Incorporated Limited to solve this problem for them. Now, before this, and this was in 2007, before recession, before the first major neural network came out. And back then, computer vision was essentially non-existent. वैसे यहाँ पे outside of the people belonging to the workshop, how many have actually used an MLAI model, no matter how basic? Some experience, कुछ भी? ठीक. So what essentially happened was they came to this company and asked them कि gave them the problem statement कि हमारे पास इतने varieties है, हम उसे पैकेज नहीं कर सकते, तो we need an algorithm जो इमेज देख के पता लगा सके कि ये बेकरी गुड कौन सा है, which at the time was completely unheard of. तब न्यूरल नेटवर्क्स नहीं आए थे, तो you couldn't just take up 1000 images, give it to a network, ब्लैक बॉक्स की तरह वो ट्रेन होगा तो मैं आइडेंटिफाई करके देगा कि कौन से इमेजेस है. उस टाइम पे ऐसा नहीं होता था. सो व्हाट उस टाइम पे कंप्यूटर विजन के प्रॉब्लम्स कैसे टैकल होते थे? नाउ लेट्स टेक अप पेडिस्ट्रियन काउंटिंग. लाइक you have an image जिसमें 15-20 लोग क्रॉस रोड्स ज़ीब्रा क्रॉसिंग क्रॉस कर रहे हैं, एंड यू वांट एन एल्गोरिथम टू टेल यू कि उसमें कितने लोग हैं. तो अभी तुम बस वो इमेज, वैसे बहुत सारे इमेजेस लोगे, उन्हें लेबल करोगे, हाँ इसमें 50 लोग हैं, इसमें 100 लोग हैं, मॉडल को दोगे, मॉडल सब कुछ खुद से सीख के तुम्हें दे देगा. Back then what used to happen was you had to identify each and every task that the model would do and find a separate algorithm for it, and then train those algorithms manually, club them together, and then see if they work together. If not, just find different algorithms, repeat. Find different algorithms, repeat until you somehow manage to hit the perfect combination, which was as tiring as it sounds in theory. So, like for example, to give you an understanding, just like this particular example of a couple of people walking, crossing a zebra crossing across the road. So the first thing, first task of an algorithm would be to normalize the colors that are present in the image. ऐसा ना हो कि कोई बहुत striking color है, for example एकदम bright red, which takes the image of the various other dull colors जो दूसरे लोगों ने पहने हो and misclassify हो जाए. So first job would be to normalize the colors ताकि सारे colors अच्छे से identifiable हो. Second task would be to identify certain regions जहाँ पे लोग actually हो. Instead of scanning the entire image, जैसे यहाँ पे cross roads हो गया, zebra crossing का जो pattern होता है वो identify करेगा to understand कि okay ऐसे regions में लोग होंगे, zebra crossing हो गया, footpath हो गया, and यहाँ पे मुझे लोग identify करने हैं. फिर once it identifies these regions of interest using maybe contours or lines, edge detection, फिर एक और algorithm आएगा जो count करेगा humans कितने हैं. Now ये count करने के लिए it might try to find a pattern in the shape of any torso plus 2 legs. So उन्हें इतना डीप में जाना पड़ता था उस टाइम पे कि पैटर्न भी बताना पड़े कि ये पैटर्न रिकग्नाइज करना है जिससे तुम्हें पता चलेगा कि लोग हैं. दैट वाज द सिचुएशन बैक देन. सो वैसे टाइम पे ये प्रॉब्लम स्टेटमेंट आया कि you have to identify you have to identify hundreds of different baked goods. And it just so happened कि the company took on the problem statement after working for it a little while. 2008 आया, recession. Now that was a well-established company, and what essentially happened was उनके बाकी सारे businesses dry up हो गए, and the founder realized कि he had staked everything on this one idea, this one product, and they were nowhere close to completion. They were just in the initial stages, and if they did not finish this product, the company would completely run. It was a sink or swim situation for them. So this added as an extra motivation for them, and essentially the kind of pipeline I told you about right now, they started working on something like that, clubbing different algorithms for different subtasks together. And within 2 years, they came up with 10 different algorithms, which had, the best of which had an accuracy of around 90% for 40 varieties of pastries. Now, during the training, 2 major problems were faced by these engineers. The first was called similarity among different kinds. Now, I'll name some baked goods. चाहिए तो तुम लोग नेट पे जाके इमेज देख सकते हो. The first is called a bacon pained d'epi, for example, which is a braided baguette with bacon inside it. Sounds weird, but लोग खाते हैं. So it has a weird structure which looks very similar to a sweet potato bread. Now, what this essentially means is 2 very different pastry goods look kind of similar. So the model had to be able to identify कि ये अलग है, ये अलग है. And another major problem that they faced was कि differences in the same kind of goods. Now, if you take a donut, a fresh donut, and keep it in the sun not in the sun, but you just keep it out for a couple of minutes, and उसका जो ऊपर का frosting है, ऊपर का powdered sugar है, जो भी है, वो melt हो जाता है. या फिर तुम 2-3 घंटे बाद भी देख लो, थोड़ा शेप चेंज हो जाता है. So the model should be able to identify कि ये जो different shape है या जो change हो चुका है, that is also the same pastry. ये भी donut है. इतना, these were the 2 major problems that they faced. इसके अलावा भी बहुत थे. So उन्होंने finally एक कुछ तो algorithm बनाई which had a 90% accuracy, which was across 50 varieties of bread. My bad, not 40 varieties. And what essentially happened was they realized कि ये तो perfect conditions में, हम यहाँ पे brightly lit area में अच्छे से फोटो खींच रहे perfect angle से, and उस पर train कर रहे हैं, वो images recognize हो रहे हैं. हम practical setting में जाएंगे तो वहाँ, can you play that video? Previous slide में, there's a video link. So this is how the model actually works in bakeries. So those green lines, and within those green lines is the name of the baked good. So as you can see, they just keep it in a tray like this. Something photographs them from above, and that's how they recognize it. So another problem they faced was that the servers could keep the pastries too close together, or the pastries could be damaged, or okay, so you know how a donut is circular with a hole in the middle. So one of the problems that they faced was how the shadow of the hole appeared based on the different lighting was affecting the results. So these are many different small problems that occurred while training, which may not occur today because we'll just put all these images in a neural network and we'll get the results directly. But since they didn't exist back then, all of these images, all of these things came up. So when they shifted from laboratory conditions to practical conditions, they encountered such difficulties. So one of the subsystems that they came up with, an additional algorithm, was to essentially look at all of these different items placed on one tray together and separate them to identify, okay, this is one different baked good, this is one different baked good, this is one different baked good. They had to develop another algorithm and add it to the pipeline, and they had to develop another algorithm and add it to the pipeline to identify destroyed pastries, which would essentially look at a destroyed pastry and in a manner reconstruct it to how it would have looked before it was destroyed, and then it was fed to the original model to identify the bakery. So you can see there were numerous tasks and it was essentially impossible कि तुम्हें हर algorithm बैठ के hand tune करना है, the amount of maths it would involve, the amount of experimentation it would involve. ये algorithm develop करने के लिए 5 साल लग गए थे. And 2012 में the first major neural network breakthrough called AlexNet was revealed. And अगर उसके बाद उनको इस मॉडल पे काम करना होता तो obviously न्यूरल नेटवर्क में डाल देते, आइडेंटिफाई करके मिल जाता. But again, this was before that. So, like I mentioned, they added these 2 new algorithms after looking at the practical settings, and again, thoda experiment kiya. They had to essentially identify each and every phenomena that was going on here. One of the phenomena that they had to work on, which kind of seems stupid now, is तुम ब्रेड को जितना ज़्यादा बेक करोगे उतना उसका कलर वेरी करता है, एंड इसके वजह से बेक्ड गुड फाइनली लुक दिखता कैसे है वो भी वेरी करता है. सो दे हैड टू अंडरस्टैंड कि कितना बेक करने पे कितना कलर चेंज करेगा. दे हैड टू मैथमेटिकली मॉडल इट एंड देन पुट इट इन द मॉडल सच दैट द मॉडल इज एबल टू रिकग्नाइज द बेक्ड गुड्स बेस्ड ऑन दैट. यू कैन इमेजिन कितना टायरिंग काम होगा, 5 साल लगेगा डेवलप करने के लिए. बट देन फाइनली बहुत मेहनत के बाद, लाइक आई सेड 5 साल के बाद, दे मैनेज टू डेवलप समथिंग. एंड आज इसके इस प्रोडक्ट की एक इंस्टेंस की कीमत है $20,000 टुडे. देयर वाज अ टाइम, देयर वाज एन आर्टिकल इन द न्यूयॉर्क टाइम्स जिसके वजह से ये इंसिडेंट सामने आया, विच वाज रिटन इन 2021, which popularized this entire story. And I read it through a Tumblr post on Instagram while just randomly scrolling. That's how I came across this. So this story became a very big thing, developing such an advanced algorithm before even neural networks came out. So yeah, today it costs $20,000 and it was developed, finally finished in 2013. And ever since then it is being used in a lot of bakeries across Japan. I'm not sure if it has gone international, but yeah, it is a very popular product there. And they went so far as to develop commercials and such to popularize this. So what happened in one such instance was that a doctor from Louis Pasteur Center for Medical Research in Kyoto saw one of these commercials and noticed that the baked goods that were being shown in the commercial looked very similar to cancer cells that he saw in his research. The shape of these cells was very similar to cancer cells. So he thought, what the hell, let's look at the algorithm. So he called up Brain Incorporated Limited and said, okay, so I noticed this. Is there something we can do about it? So they invited him, they worked together for a little while, and they essentially came up with something called Cyto AI scan algorithm, which could identify these cancerous cells, and it had over 90% accuracy, which was pretty amazing because this was originally developed by baked goods. In an interview, when the founder was asked what is different about the cancer identifying algorithm and the baked goods identify algorithm, he said they're pretty much the same thing. Like they are literally the same thing with very few minor changes based on circumstance. So can you imagine like being able to understand your product so well that you can just say, हाँ कि cancer पे भी काम करेगा. And not just that. So this is an excerpt from the New York Times article. AI scan algorithms have since been used to distinguish pills in hospitals, to count the number of people in an 18th century woodblock print, to label the charms and amulets for sales in shrine. One company even used it to automatically detect incorrectly wired bolts in jet engine parts at at the S-Spring 8 angstrom compact free electron laser in Hyogo, a 700 meter long experimental apparatus which produces high intensity laser pulses. Since reading the millions of resulting images by hand was practically impossible, this particular AI scans algorithm was used to help them with that problem. So can you imagine this algorithm which took them 5 years to train for detecting bakery goods today has all of these different algorithms, all of these different applications. Now this was only possible because they properly understood what their product was. They understood कि this part does this part does this, हम इसको change करेंगे तो ये होगा, हम इसको change करेंगे तो ये होगा. And that is how after very less effort they were able to expand the different applications that are available. And one very important, you could say, feature of this algorithm which sets it apart from even the most modern deep learning architectures is that, say you trained it for 100 different varieties of baked goods and the bakery comes up with a new product, 101st variety, and you want to add that to the entire list. So for a deep learning architecture, what you would have to do is take hundreds, even thousands of images of the new baked good, fine tune the existing algorithm, and then the model will be able to identify it with 80 to 90% accuracy. In this case, the founder swears by this publicly, and obviously it has been experimented with. You show one image of the new baked good to the algorithm, it has a 40% chance of identifying it. After 5 images, it is more than 90%, and after 20 images, it is nearly perfect. Just 20 images. That is what sets it apart from using any deep learning architecture to replace this. Because the company tried and saw that this product was much superior to any deep learning algorithm. Doesn't have any neural networks, it is just stitched together by hand, and this is much better than today's neural network architectures. Can you imagine just the power of this? And another important question this raises is the explainability of AI. If you look at any healthcare application of AI, if you're giving a trained neural network architecture to a doctor and nothing is 100% accurate, there are bound to be some cases where it detects something false. कोई cancerous cell होगा जो ये miss कर दे, या फिर you look at the heart monitor जहाँ पे ECG दिख रहा है, so it may not be able to detect arrhythmia or something, miss हो जाए गलती से. So the doctor should be able to understand कि क्यों miss हुआ. The doctor should have some explanation to give to the patient's family कि हाँ ये algorithm हम use करते हैं, ये इस reason की वजह से fail हुआ, which is perfectly normal. जो होता नहीं है, क्योंकि it's a black box. तुम्हें पता नहीं है कि अंदर क्या चल रहा है, क्यों गलत आ रहा है, क्यों सही आ रहा है. And that is why these algorithms are not widespread in healthcare जितना होना चाहिए. क्योंकि डॉक्टर्स बोलते हैं कि हाँ हमें समझ नहीं आ रहा क्यों चल रहा है तो हम क्यों यूज करेंगे. And that is a major drawback. इसीलिए इतने powerful algorithms होने के बाद भी हम यूज नहीं कर पा रहे. And something like this जो neural network से पहले निकला था, that can be used freely because since हर चीज उन्होंने खुद से बनाई है, उन्होंने manually fine tune की है, manually stitch together की है, they understand कि इसमें exactly क्या हो रहा है, कोई भी चीज सही हो रही है, कोई भी चीज गलत हो रही है, they're able to pinpoint कि हाँ यहाँ पे ये चीज ऐसी है, ये equation ऐसा है, या ये मॉडल इस चीज पे trained है, इसलिए उसने ये mistake की. That is the power of a simple architecture like this. And pastry से again cancerous cells पे आ गया. And today this same algorithm has पहले जब बना था, its power was कि वो एक सेल आइडेंटिफाई करेगा, फिर एक सेल आइडेंटिफाई करेगा, फिर एक सेल आइडेंटिफाई करेगा. आज उसकी पावर इतनी है, if you give it a whole slide of cells, वो immediately तुम्हें बता देगा कि ये सारे cells cancerous है. It has reached that capability. If you just replace this with a neural network architecture, तुम बेक गुड्स पे ट्रेन करोगे, वो कैंसरस सेल्स नहीं आइडेंटिफाई कर पाएगा क्योंकि वो सब कुछ साथ में ले लेगा एंड इट विल बी कंप्लीटली फाइन ट्यून टू द बेक्ड गुड्स. वो उस पर ठीक ठाक परफॉर्म करे आफ्टर हंड्रेड्स ऑफ थाउजेंड्स ऑफ इमेजेस, बट वो कहीं और नहीं अच्छे से परफॉर्म कर पाएगा. यू नीड अनदर स्पेशलाइज्ड डेटा सेट फॉर इट टू परफॉर्म लाइक दैट. So one last addition to this particular test case, when COVID came, pastry goods को pack करना पड़ा था for hygiene reasons. So again, one of the problems that they faced was कि packed goods में reflection आता है, shine आता है, या फिर shape थोड़ा distort आ जाता है because of the packing. तो baked goods इनका algorithm अच्छे से काम नहीं कर रहा था. So they came up with a very simple solution. उन्होंने एक simple neural network उठाया which would take the packed goods का image and showcase it how it would look like without the packaging. And वो उन्होंने अपने existing model में feed कर दिया. this was it. They just had to add one simple, very small neural network architecture to be able to shift from a packed code to a completely unpacked code. Now, I wanted to discuss this particular case study in a beginner's ML workshop because this highlights the fact that you need to understand your work. कोई भी पाइथन में जाके लॉजिस्टिक रिग्रेशन ब्रैकेट लिख के मॉडल ट्रेन कर देगा, बट अनलेस यू अंडरस्टैंड कि अंदर एग्जैक्टली क्या हो रहा है, ये मॉडल कैसे काम करता है, इसके ड्रॉबैक्स क्या है, यू वोंट बी एबल टू प्रैक्टिकली इंप्लीमेंट इट आगे जाके अच्छे से. क्योंकि तुम नेट पे जाओ, तुम्हें हर चीज़ का कोड मिलेगा. लॉट ऑफ आवर वर्क जस्ट इन्वॉल्व्स नेट पे जाना, हर छोटे छोटे चीज़ का कोड निकालना, उसको थोड़ा सा चेंज करना, स्टिच करना एंड चलना. Anyone can do that for you to, and considering ML जितना upcoming field है, everyone will have to learn some aspect of it at some point in their careers in the future. So to set you apart from what everyone is doing, you need to understand कि काम में क्या जा रहा है, काम में कैसे क्या हो रहा है. Without that, it's gonna be pointless. तुम कुछ भी उठाओगे, बोलोगे हाँ ये ऐसे ट्रेन करके मैंने दे दिया, बट ये क्यों हो रहा है, क्या हो रहा है, without properly understanding that, उसका value drastically decrease हो जाता है. And again, coming to models like ChatGPT, जो मैं भी अपने assignments के लिए use करता हूँ, models like this in today's age have become to a big extent a crutch for programmers and even for students. हम उन्हें हमारी knowledge expand करने की जगह हमारा काम कम करने के लिए use कर रहे हैं, which is again one of the reasons why they were developed, but that should not be a crutch for us कि उसकी वजह से हम handicap हो जाए. That should be a tool जिससे हम सोच सके कि हाँ मैंने इतना काम किया है, ये और कहाँ तक जा सकता है. That is the mentality which we should have while using that we should be having while using such advanced ML tools. That is why they were developed, not to restrict us further. कि हाँ मॉडल को ये सब आता है तो मैं ये सीख के क्या करूँगा, इसलिए मैं ये सीखता नहीं हूँ. The models can only take us so far. There is a common misconception कि ML, artificial intelligence and these things are replacing jobs, when in fact what they're doing is they're creating new jobs. So for you to have an access to those new job markets, you need to actually be able to understand AI properly. Without that, you will end up being a slave to them. And all the theories ki AI takes over, Terminators aa gaya, all that blah blah nonsense, that will end up coming true, but just for you. If you don't understand how AI works, you won't be superior to them. There's no point in it. It will just end up doing a job better than you, and you will be out of a job. And that is the crux of the matter. You need to understand it to be able to beat it, to be able to be better than it. If you don't understand it, you will be out of a job. That is the problem here. So with that, I would like to end my speech and pass it on to Yatharth.
So first of all, I would like you guys to, give a big round of applause for him, guys. So as all the speakers today have portrayed the different areas where ML can be used and where it cannot be used, and how algorithms could be superior to ML, and sometimes, and most of the times they are actually. But still, how can we get into ML? How can we improve that? How can we actually get something that is like this? So that would be coming under the explainability and interpretability of AI. So as you saw about diffusion, ChatGPT, generative models, and reinforcement learning and all, we'll be going into detail in the workshop this evening about natural language processing. We'll be starting you up with some basics of natural language processing, and we'll be getting you till building your own ChatGPT, and that you can run on your computers, that you can use. So I hope that you guys enjoyed this workshop. I hope that you learned something. So please do attend today's evening workshop as well. A big round of applause for today's speakers, and let's end it. Thank you everyone for coming.